Dear students, in the last class we were studied about the introduction to integrated circuit, introduction to transistor. As we know that in MOSFET mainly we have two types. One is NMOS transistor and another one is PMOS transistor. So now in today's class we're going to understand what is the operation of NMOS transistor. So as we know that here the figure shows the cross section view of NMOS transistor. If you observe this figure shows a cross section view of NMOS transistor. If we are constructing an NMOS transistor, the body is of P type. If it is an NMOS transistor, the body should be opposite, which consists of P type. Here, the NMOS transistor is built with two adjacent N-type regions of source as well as drain. In between, we have gate terminal. So that the NMOS transistor has mainly four terminals. The first one is source, the second one is gate, the third one is drain. Apart from this, we are also having a fourth terminal. We can call that one as body terminal. So here you can observe this figure. So the gate consists of two important layers. The first one is a good conducting layer. We can call it as polysilicon. The top layer, it is a good conducting layer. We can call it as polysilicon. Below this, we have tin oxide layer called as SiO2. Below the polysilicon, we have thin oxide layer. We can call it as SiO2. This SiO2 acts as a insulator. So that's why we can call this transistor as NMOS transistor. So here you can see the symbol of an NMOS transistor. So mainly it consists of three terminals: source, gate, as well as drain. Next, we're going to understand operation of an NMOS transistor. Usually, in NMOS transistor, the body terminal. So here we are having the body terminal. This body terminal should be connected to ground. The body is usually tied to ground. Suppose if the applied gate voltage is low, or you can say that when the gate is at low voltage is nothing but it is connected to ground. Ground means its value is 0. When the gate is at low voltage, even the body is also at low voltage. Here, the source and drain bodies are off. So when the gate is at low voltage, it is connected to ground. When it is connected to ground, the transistor is off. When the transistor is off, there is no conducting path. When there is no conducting path, there is no current flows from source to drain. So here you can assume, so when we are applying 0 at the gate voltage, when we are applying 0, even the body is also at low voltage. So the transistor is off. There is no conducting part and there is no current flows from source to drain. Suppose if the gate is at high voltage, which means that if the gate value is 1, if the gate value is 1, so there will be a positive charge on gate of the MOS capacitor. Here we are having some positive charges. Even the body is of holes. So there will be some attraction towards the charge carriers that forms the channel. When there is a channel created, the current flows from source to drain. At the time, the transistor is in on position. So here you can remember, when gate voltage is low, which means that if its value is 0, the transistor is off. There is no current flows from source to drain. When the gate voltage is 1, at that time, the channel is created and there is a current flows from source to drain terminal. So this is an operation of NMOS transistor. So next we're going to discuss with PMOS transistor. So the PMOS transistor is similar, but it operates reversely to the NMOS transistor. So here you can observe the cross-section view of PMOS transistor. So it is also consists of 4 terminals: source, gate, drain. Apart from these 3, we are also having one more terminal. We can call the terminal as body. So whenever you are constructing with PMOS transistor, the body usually opposite type, that is N type. And the gate consists of 2 layers. One is polysilicon gate and the second one is SiO2. So here the operation of PMOS transistor is similar, but doping and voltages are reversed. So here we are having P plus source and drain regions, but the body is of N type. And usually in the NMOS transistor, the body tied to ground, but here in PMOS transistor, the body tied to VDD. When gate is low, which means when the gate value is 0, the transistor is on. When gate value is 1, we can say that the transistor is off. Because the PMOS transistor performs complement, or we can say that inversion. Because of that reason, if you are providing 0 to the gate, the transistor is on. If you are providing 1 to the gate, the transistor is off. In PMOS transistor, the bubble indicates inversion. Here you can see, so this is the symbol of an PMOS transistor. This bubble performs complementary, or we can say that inversion. So if you are providing 0, 0 should be transferred to 1. At that time, the transistor is on. Suppose if you are providing 1, 1 should be transformed to 0. At that time, the transistor is off. Next, we're going to discuss power